In this lecture, we're going to discuss manipulating numeric data. Previously, we've talked about creating variables, and we've talked about the numeric data types. Now we're going to talk about some of the operations we can perform on these numbers and how those operations work. We're going to talk about the basic mathematical or arithmetic operations. We're going to talk about the order of operations in Java, the way that Java applies the rules that go along with order of operations. We're going to talk about this idea of what is called the unifying type. It happens when we try to do operations on numeric values that belong to different data types. We're going to talk about changing or converting one data type to another. We're also going to talk about some shortcut mathematical operators. Let's first start with the arithmetic operations, your basic mathematical operation, adding, subtracting, multiplying, and dividing, as well as an operator called modulus we'll discuss. Let's go over the basic operators. First, we have the addition operator. We've seen that before. It adds together the number on the right and the number on the left. You can see an example of it in the example column. 1 plus 1 equals 2. We also have subtraction. 3 minus 1 equals 2. We have multiplication. You'll notice that is the star. Also, it's the key above. It's the symbol above the letter 8 key on the keyboard. We have division, which is a /. And then we also have this operator that is the percent sign, which is not actually a percent. It is called the modulus operator, or the remainder. It provides us the remainder after long division. This is probably a new one for most of you. If you remember back to elementary school math, when you were first learning to divide, we didn't turn numbers we didn't get decimal answers right away. Instead, we figured out what would divide evenly, or we figured out the closest number that would divide evenly into the number under the division sign. And as long as the number we got back was a little smaller than the number on the outside of the division sign, it was called the remainder. And what the modulus does is allows us to determine what this remainder is. Very useful if you need to determine when a value is evenly divisible by something. In other words, when there is no remainder left after division. These rules have sort of an order of operations. There is an order in which these mathematical operations will occur. It's very similar to the order that we learned in math. If you look at the examples on this slide, I am asking you to tell me which one is correct. Is the first box correct or the second box correct? Now, a lot of people, especially for those of us who have been out of math class for quite some time, would think that the first box is correct. 3 plus 2 is 5. 5 times 6 is 30. However, that is not the case. The rules of operation, the order of operations in math, at least that I learned in school, was multiplication and division come first, from left to right, then addition and subtraction. In this case, that would make the second box correct. First, we do the multiplication, since that's the only item out of the ones that are done first up here in this problem. 2 times 6 is 12, and then we add 3, since addition and subtraction come second. So again, the order of operations are multiplication, division, and we're going to add modulus in there as well. Multiplication, division, and modulus come first, followed by addition and subtraction. The question is, what happens if we don't want that to occur? What happens if we want 3 plus 2 to be processed first, as opposed to 2 times 6? To do that, we can use parentheses. Parentheses interrupt order of operations and allow us to tell the computer, and of course anyone who is doing this problem by hand, which operation to do first. In the first box, we see parentheses around the 3 plus 2. We do what's inside the parentheses first. That would be adding 3 plus 2. Then we multiply the result times 6. In this case, it would be 3 plus 2 times 6 equals 30. Again, this is different than what we do below, where we multiply 2 times 6 first and then add 3. When we're talking about mathematical operations, we may encounter a situation where we have a decimal number, like a double variable, and we add or subtract or multiply or divide that number by, say, an integer or a float. We need to know how Java will handle this operation. Generally speaking, when we do mathematical operations on data of the same type, for example, 2 ints or 2 floats or 2 doubles, it's very easy. The answer that Java is going to return to us is going to be of that type. So if we add 2 integers together, we're going to get an int. If we add 2 ints together, we're going to get an int. If we multiply 2 floats, we're going to get a float. If we divide 2 doubles, we'll get a double as our answer. This is important because if we choose to store the result of some mathematical operation in a variable, we need to make sure that we're providing a variable that is the right type. So this is pretty much easy. 7 plus 5 is going to give us back an integer. 1.2 times 1.2 is going to give us back a decimal number. That part is easy. One of the things, though, that this rule that Java has, one of the problems that opens up for us is the idea of integer division. Remember what I said. When we do mathematical operations on an int and an int, we're going to get an int back. That means if we divide an integer by an integer, we're going to get an integer back. If we look at 5 divided by 2, it's really 2.5. However, because 5 is an integer, a literal integer, but an integer nonetheless, and 2 is a literal integer, we're going to get an integer answer. That instead of rounding, however, Java just drops off any fractional amount. Now, we talked about the different data types last week. And while byte and int are both integer data types, a byte uses 8. A byte is 1 byte in size, and an int is 32 bytes in size. Takes up 32 bytes of memory. So if I do a byte and an int, I need to know what kind of data I'm going to get back. If I multiply a float and a double together, I need to know what kind of data I'm going to get back. If I divide an integer and a double together, I'm going to need to know what kind of data I get back. So what's the rule on this? Well, there's something called the unifying type that Java does in order to figure out what kind of data to give you. Java only really knows how to do math problems when both sides of the operator, when the number on both sides of that operator symbol are the same. Or I shouldn't say are the same, but are of the same data type. So what happens is Java promotes all the other data types in the equation to some unifying type. Usually it's the largest type in the problem. However, the order is we'll show you the order of progression. Basically what happens is if I'm adding a float, which is a decimal number with 6 or 7 digits after the decimal point, and an int, which is an integer number somewhere between -2 billion and positive 2 billion, what Java does is Java promotes that integer to a float. So Java converts implicitly that int into a float. And we all know what happens when we add two items of data of the same type. We get back that type. So an int plus a float will be converted to a float plus a float, and the result is a float. Now remember, we're just talking data types here. We're not actually doing a math problem. But I will illustrate this in class when we meet again. The order of promotion. The unifying type principle is this idea that we will elevate the lower items in the equation to the same data type as the highest item in the equation. That means if I'm adding a byte and an int together, if you notice byte is at the very beginning, int is in the middle, int is the higher value, that byte will be converted to an int and we'll add an integer and an integer. Same thing with a float to a double. While they're both decimal numbers, the float is the smaller, less precise value. The double is the larger, more precise value. So the float will be promoted up to the double. This gets a little bit confusing, and it can get a little bit confusing. We will see some examples of how this can work for us or against us in class when we meet. There's also this idea that we can force Java to change the data type of a value into something that is what we decide we want it to look like. And we do that by placing the name of the data type in parentheses in front of the item we wish to convert. For example, let's say that I have an integer. I declare an int variable. That's an integer that is between negative 2 billion and positive 2 billion. And I want to store in that integer 31.56. Well, I can't really do that. As we know, we cannot store a decimal number in an integer variable. However, what I can do is I can typecast that literal decimal, which will force it to be stored as an integer. When we convert a decimal number to an integer, I have to warn you, we basically lop off everything after the decimal point and pretend that it doesn't exist. No rounding occurs. The last thing I want to follow up with is some shortcut mathematical operators. We have a number of shorthand mathematical operators, some of which we'll discuss in the future as we move on to other topics where they become more useful. Some of these I'm probably going to show you here, and we probably won't see these again. The first one is called an increment operator. It is plus plus, and what that does is cause 1 to be added to the current value of the variable and stored in the result stored in that variable. So it's basically like, let's say we have a variable I. It'd be the same thing as saying I equals I plus 1. What that statement says is we're taking the value of I, we're adding 1 to it, and then assigning it back to the variable I. Decrement does the same thing, except think of subtraction. So we're taking the value of I, taking one away from it, and storing it back in I. Plus equals allows us to take the idea between the rest of these shortcut operators is the idea that if we are taking the value of a certain variable, adding or subtracting or multiplying or dividing something from it, and storing it back in itself, for example, we're taking x, we're adding y to it, and storing it back in x, we can use these shortcuts. So x plus equal y is a shorthand way of writing x equals x plus y. Minus equals, same thing. X minus equal y is the same as saying x equals x minus y. So on and so forth the whole way down the list. You might be asking yourself, what is the advantage to this? And quite frankly, the advantage is one or two characters less you have to type. Personally, I don't find myself using these very often. I am very much of the school of what we call self-documenting code. When we talked about variables, I mentioned that in variable names, I like to choose descriptive names that really let someone who's coming in and looking at my code know what that variable does and is for. In this case, I prefer to write out the full statement so that anyone who's looking at my code knows exactly what I intended without having to try to make sure they understand the whole idea of the shortcut operator. I don't find myself, and these shortcut operators are available in every language. They're slightly different depending on the language, but they're in all of the languages, and I don't find myself using them very often simply because I prefer to spell everything out for anyone who might look at my code. But they are here, and they're available for your use. There really isn't much to talk about. Addition, subtraction, multiplication, division, and modulus aren't very exciting topics, and seeing as most of us have gone through elementary and high school math, we understand these operations and how they work. There are some tricky items that I will cover again in class. I will talk about when we meet again. However, that pretty much concludes our discussion of, or our introduction to, operations, the order of operations, and how they work. If you have any questions, of course, feel free to email me. Otherwise, I will see you in class. Thank you.